Hello everyone. In this particular lecture, we'll be discussing about variables in C++. Variables in a C++ language are again a very important concept that you should be aware and you will be using. By the term variable is something that is changing and is able to change. So in the same context, in any programming language, we have variables. Now these are the names given to the memory location, and they are used to store some values that can be used in the program. So they identify a memory location by a name and it acts as a container. Therefore, it is acting as a container that is used to store some values, and this value is the value in that particular memory location. Now, variable may change during the program execution. That I have said that its values may change, but at a given instance, it is always having a single value. That is, it can only have one value at a given instance. Now, rules for naming the variables, that the name should be the same rules are applicable as we discussed in the identifiers, and the rules of naming variables should be thus that the name should be descriptive and it should be a noun. So in this regard, we have to ensure that these particular rules are followed. Then some of the examples are total, daily sales. As it is a multi-word variable, you have to ensure that these particular rules are followed. Next comes a variable. Now, a variable must be declared before using it, and it must have a name and a data type associated with it. Now, you can see here I have declared a variable length and it is having an int data type. Now, this is a variable declaration. I can say this on encountering this, a memory is reserved for them. Therefore, it is acting as a variable definition also. So compiler reserves memory for this particular variable. But there are some variables declarations which are not variables definition. So it is, we can say that all variable definitions are implicitly variable declarations, but the reverse is not true. इसका ये मतलब है कि अगर हम बात करें कि declaration definition, एक वेरिएबल डेक्लरेशन डेफिनेशन तो होती है, बट एक आधे केस में वो नहीं भी होती, जैसे कि एक्सटर्न वेरिएबल हमने बताना हो तो ये वेरिएबल डेक्लरेशन तो है, डेफिनेशन नहीं है. इसी तरह ये फंक्शन की डेक्लरेशन तो है, डेफिनेशन नहीं है. बट यूजली वेरिएबल डेक्लरेशन, जैसे ऊपर के केस में इंट लेंथ लिखा हुआ है, इसमें हमारे पास वेरिएबल जो लेंथ है, इट इज हैविंग द variable, it will give given the memory, therefore it is acting at a variable definition itself. Now variables are assigned values, and these values should be some numbers depending upon the type, and if that value is out of range, then it should be taken care by the compiler what value will be assigned, but one should always provide the values within the range, and it can be a number, literal as it is provided here. It can be an expression. Some expression can be evaluated and assigned to this particular variable. So they must be ensured that you should assign the value, and we have discussed this earlier also. So if you do not initialize a variable, the compiler assigns 0 to non-local variables or a garbage value depending upon the storage access specifier. So it is up to the compiler that what type of values you are making. So it will usually assign a garbage value or a value 0 in case of non-local variables. Okay, like we have extern and all that. So if you assign a value out of range, then you may get unexpected results. Now we shall discuss a program to show how variables are declared and initialized. So I am declaring a variable length. Now this variable is a variable declaration. Now I will be writing about this. So you can check whether this variable is assigned some value or not by printing this value, cout, and let it be length. By default it is local to the block which is defined because its default storage class is auto. Now if I save it, Control S, and I run this particular program, so you can see we are having the garbage value that is printed. And if I put static over here and save it, and now I run it, so it will be having a value 0. So you can come across that when it will be having a value 0 or when it will be having the garbage value. Okay, so next, this value is having some value associated with, and it is a variable declaration. Okay, so I write variable, it is declaration or definition, both same because it is getting memory. Okay, next is I assign some value to it, and this value will be assigned to this. Now let me run this particular code, so it will be printing this 10 value. Okay, now let me introduce the concept of scope of this variable. Let me declare a variable, and in this scope int, let the variable name be y and let it be 30. Now if I print this value here, now let's see what will be the value that I will be getting over here. Okay, 30 and 10, I should have added underline for each so that it could separate the values on each line and it is more visible. Now this value cannot be accessed over here, so if I try to print the value of y over here, let's see what is the message that we are getting. So it is saying that y is not declared in this scope because its scope is not visible here. So its scope ends up with this particular closing brace, and length is declared within main and its scope end up with this. We can also think of adding a function call. Let me add a function call and pass a value to it, or you can simply make a function call. Let us say a function call, and for this function call I add a code. I've added void, but it is always recommended that you only add when you don't want to return a value. So let me declare a variable num and is equal to 50 and print this particular value. So let's see what is the output. Let me remove and make the zoom. Okay, so save it and check for the result. Okay, so okay, I have to correct over here. I have to put the variable name length. Okay, save it and run it. So you can see the different values we are getting. It is first the value that is y, that is 30 is printed, then function call is made which switches over there. Now if I try to print the value of num here, you can see whether it works or not. So again it is not declared in this scope, I cannot do so. And similarly if I try to print the value of num here, so let me see, it will again give a message. So you can thus come to know what are the initial values that are assigned to a variable, what is the scope of the variable, where it ends, and you can also come across that this particular variable uh, is assigned some garbage value that we have seen. Okay, so you can also make it to be double. Now this value can be something like this. Now 10.5 is a literal, and this is a floating point literal which is assigned a value to the double. So it is this value, that is length, will be having. Now let me print this value length and now I correct it. So this is how variables of different types can be declared. We have already done in literal, so 10.5 is printed over here. So this is how the things happen in case of variable declarations. Now variable declaration and definition are same over here, but if you consider that you have to declare a function, and like this we have made it earlier. So if I shift it and add it in the later part, let me do it. So let me save it again. So it is saying that it does not know the function. In that case, I have to put a function declaration and now see that it works or not. So it is now working. So we have to put function declaration whenever we call a function before the function definition. So this is the function definition. You can clearly see they are separate. They are not the same as we have discussed in case of variables. So variable declaration, function declaration, function, this is definition, and this is spelling mistake, and this is function declaration. So this is variable declaration, and we usually and we can say it to be a definition also. Okay. There are the time at which a variable has valid memory. It is called its lifetime. Now this lifetime of a variable is specified using storage access specifiers, and usually extern, register, auto. Then thread local is introduced, and register has depreciated. So these storage access specifiers are used to specify the lifetime of a variable, that is the time for which the variable has a valid memory. So that a variable declaration is usually prefixed with this storage class specifier, and this particular is by default, if not specified, automatic scope, but the word auto has been depreciated. Automatic storage class has been auto specified using auto. It has been depreciated with C++11. Then the next important thing we should be aware of is the portion of program in which a variable name is in effect determines its scope. That is a scope. What is a scope? Now every variable has a lifetime and it also has a scope. Now scope is in which that is the variable name can be used, or you can say it is available for use, you can say. So in case of local scope, we can say when that particular variable is declared within a function, it is within a statement block in curly braces, including parameters, all that, and once that particular closing brace is exited, it reaches out of block. So such variables are often called local variables. Then we have class scope. Class variables, class scope means the variable visible only in the class definition, and as it goes out of class, its scope diminishes. So accessibility of the member is further controlled with the help of access specifiers, and we will discuss while going through the lecture of classes. Next, we have namespace scope. Namespace scope is visible within the namespace, given namespace, and may stretch multiple scopes. Next is global scope. That is, it is declared outside the class, and we have shown in the global variable declaration that this scope extends throughout the end of the file. So this is depending upon the scope. Next is a variable can be assigned different values. Now here, in the starting, we have initialized it to be a value of 50, and then later on in the program we have made it to be 35. So this is a variable can be assigned different values during the program execution, but it retains the most recent values that has been assigned. Now if speed is initially assigned 50 and later on it is assigned 35, then it will be having the latest value of 35 that will be assigned to it. Similarly, we have to ensure that if a variable speed is of particular type is declared, you cannot change its type. So you can change the value of the variable, but you cannot change its data type within the same scope. So this has to be ensured. Now this program shows local and global variables. I have declared a variable x within the namespace. This is a variable that is a global variable, and this is a variable which is having a local declaration. Now all these variables have the same name. Now let's see if I want to access these values. Now x is declared within main, so it has the highest visibility over here, and it will be accessed. So if I print the x over here and try to run this program, I will be getting this value. Now 10, to get the value of the same name variable, a global variable, I have to put scope resolution operator, and to get the value of the namespace, I have also to enclose the value of the namespace along with this. Now what if I declare it within a block? So its scope will be limited to the block. So in that case, if I put a remove x over here, and try to run this program. So you can see it's working still correctly. This is just because the scope of this particular local variable is limited to this block, which ends with this purple colored closing brace. And therefore X will be uniquely identified as a global variable, and this global variable has a scope till throughout the program, and therefore it is visible over here. But had this been not there, and I would have tried to use X as such, then in that case it would have said me that it is 10 and 10. So this 10 and this 10 resembles a lot. Okay, you must ensure that the values are printed. Okay, so if I do make it like this also, you can think of, I make these changes. Next important thing we should be aware about variables. Multiple variables can be declared, and if multiple variables have to be declared in a single statement, they should be separated by comma. So you can see num1, num2 and sum, these all are separated by commas. So this is important that when you are declaring multiple variables, the comma separator is required. And next is the name of the variable in the declaration can be modified with brackets. That is, you can declare an array, as monthly sales here is indicating that with this bracket the variable name is modified, hence it is acting something like derived and it is an array. Then we have a pointer to a character, then we have a function to add two numbers, then we have a pointer. So all these brackets and different brackets have different meanings, so therefore we can modify the meaning of the variable. Then in C++11 the auto was again redefined, and auto was declared as a data type that is used to determine the data type of the variable declared at compile time. So it is very useful. Its most basic use, let the compiler deduce the data type. So compiler automatically deduces the data type. For example, if you write auto size is equal to 10, it means that the size will be of type int. Then if you write auto b is equal to a, where a is of type double, then it will be automatically deducing that the type of b is also double. So it should ensure that the following point should be remembered while working with variables. Okay. Now let us consider a program to show that we can declare multiple variables in a single line and use of auto. Now let int x and y is equal to 10 and let x is equal to y and initialize in the same statement. So this simply prints x comma okay int x y semicolon. So let's see what will be the value of this particular output of the program. Save it and I run it program. So you can see there 5 and 10 values are printed as such. So you can declare multiple variables in a single line in such a manner by separating each variable declaration by comma, and the last ending with this particular statement should end with a semicolon. So now let's proceed to auto variables. Now if I don't write here, okay, first let me remove this. I check with first variable. Now C++11 redefined the keyword auto, and it is now used by the compiler to automatically deduce the data type and of the declared variable, and it is very helpful, or the variable, or you can say lambda expression parameter also. So in this case, if we don't write int and let the compiler deduce the data type, so this is, and let me remove y, control and run this program. So you can see a 5 is printed because it has reduced. Now let me take, now let me first print the data type of this variable to check what will be the data type also. So I can write for data type, a function is there, type id, and this takes a value of the variable whose type is to be determined, followed by a dot operator and name and semicolon. So let's see because type ID has been used, so we have to include type info file, save and run. So you can see 5 is the value that is being printed over here, and along with that you are having the type ID, which is basically indicated by I character over here, indicating it is an integer. If you change it to be some value to be that of double, so you can check whether this value, there will be some different answer or the same answer. So you can see D is overwritten over here, indicating that it is of type double. Similarly, let's see what is there if we put A. So we can have C to be the character, but if you really want to print the exact name of that particular type also, then you can also do it. Let's try it by adding the following. Now this is, so you can now get the value. You can again check if you want to have different value, it will give it the exact value. Let it be 40.5. It will give the appropriate message. You can check over here, double is printed. So this is how you can print the exact value name of that character, but otherwise type ID X is easier to remember, so you usually add this way. And you can also write 4.5 F, save it and run it. So this is how type auto behaves when it is used in C++11 and later, that it helps the compiler to automatically deduce the data type of the declared variable. So there is much more detail of auto. We will be discussing it later. Okay.